Today, environmental issues are a growing concern. New technologies and techniques are currently being developed to utilize the resources that the Earth already possesses. Reusing CO2 to obtain oil in a more energy efficient way, making use of renewable resources such as wind and solar power, new developments for water filtration are the main focus of our research.
One technology which could reduce greenhouse gas emissions across the world is carbon capture and storage. This is the process of capturing waste CO2 from large-scale sources such as fossil fuel power plants and Canada's oil sands, then transporting it to a storage site and depositing it deep underground, normally in a geologic formation so it does not enter the atmosphere. According to Alberta Energy, North America has enough storage capacity for more than 900 years worth of CO2 at current production rates, and Alberta has committed $11.3 billion over 15 years to fund two large-scale carbon capture and storage projects, the Quest project and the Alberta Carbon Toon Link project. These projects will reduce Alberta's greenhouse gas emissions by 2.76 million tons annually, beginning in 2015. This is equivalent to taking 550,000 vehicles off Alberta's roads. This technology is also used in other provinces in Canada besides Alberta. For the past 9 years, Cenovus Energy has been using waste CO2 at the company's Weyburn project in southeastern Saskatchewan to recover more oil from their aging reservoirs. The CO2 is pumped into the reservoir, which allows oil to move more freely. Then water is injected to flush out oil trapped in holes and cracks. Then the oil and water mixture is pumped to the surface. The best part about this process is the CO2 remains in the reservoir, and it also increases the amount of oil recovered. According to the Canadian Association of Petroleum Producers, to date more than 13 million tons has been stored at the site. This equates to the emissions of 6.7 million cars over 1 year just at that one project alone. The technology of carbon capture and storage is a great breakthrough and has potential to make a difference in reducing greenhouse gas emissions. However, it is only part of a portfolio of solutions needed to solve the problem. We also need to focus on more sustainable, low-impact solutions, like using more renewable resources.
With improvements in technology, we're able to unlock and improve renewable energy like solar, wind, and hydropower. In Germany, they have the highest capacity of solar voltaic power in the world. The German solar panels generated about 23 terawatt hours of electricity, which is only 3% of their electricity that is used today. But market analysts project that this number will increase to 25% by 2050, according to energyinformative.com. The first GE 2.5 120 wind turbine was also installed in Germany. The anticipated production rate of 8 million kilowatt hours is equivalent to the required average energy of approximately 2,000 German households. It uses the industrial internet and data analysis to connect the machines together to enhance efficiency and performance, according to wind power energy development. Modern hydro turbines can convert as much as 90% of available energy into electricity. Hydropower is the leading source of renewable energy on Earth today. In the US, 81% of the electricity produced by renewable resources comes from hydropower. And although it is more useful in some places than others, 75% of electricity in New Zealand and 99% of electricity in Norway come from hydropower, according to altenergy.org. Though technological advance will increase efficiency and productivity of these renewable energy resources, also with advance in technology, we are able to solve the world's water issues.
There is a great abundance of water on our planet. However, according to the U.S. Geological Survey, about 96.5% of our water is in the oceans, making it difficult for drinking, cooking, and cleaning. In addition, many of our freshwater resources are contaminated due to pollutants from anthropogenic sources such as human waste and runoff from factories. The USGS studied the water quality of over 2,000 private wells in 2009 and found that about 23% had at least one contaminant at a level of potential health concern. So, given that most of our water is undrinkable, how do we ensure that there is enough clean drinking water available for everyone on our planet today and enough for future generations? The key to our longevity is in both large and small scale technologies. Desalination plants are one way of converting ocean water into clean drinking water, although most come with a hefty price tag and a capacity to produce vast amounts of CO2 emissions. According to Bloomberg magazine, an increase in desalination plants could increase our greenhouse gas emissions. Plus, they state that the Beijing Power and Desalination Plant costs roughly $4.1 billion to create, which is a price many countries will not be able to afford. Desalination could be the answer in the future, especially as alternative energy sources become more readily available. If a demand for desalination grows as our freshwater resources become depleted, the possibility of hydroelectric-powered desalination plants popping up around the globe isn't that far-fetched. But I think the key to addressing our current water concerns is to think much, much smaller. Many brilliant water filtration devices are being invented all the time, some cheap enough that they could be feasibly implemented in even the poorest regions. The Life Straw is one such example. This low-tech but ingenious product developed by Vestgard makes contaminated water safe to drink and can filter 1,000 liters of water. And according to the company's website, the more advanced products in their lineup can provide clean drinking water to entire communities in developing countries. Many other personal water filtration devices are also able to desalinate, such as products from hydration technology innovations. More and more technologies are being created every day to meet the world's growing needs for clean, desalinated drinking water. The world does indeed have an abundance of water. The key to accessing it is technology.
So what should we do as students?
Well, I think the key is educating ourselves. So taking courses at the university on geology and environmental science and environmental engineering, just to name a few.
Sounds good to me.